number representations. A couple of these should be familiar to you. One is probably new to the large majority of you. And then one of the familiar ones will be adjusted slightly from what you have probably been exposed to. So make sure that you see the differences. Hey, there's three types of number representations that you need to be familiar with. The first is inequality notation. The second is graphical notation. And the last is the new one for most of you, which is interval notation. Inequality notation is the one that you guys are probably the most familiar with. So if I gave you something like this, x is less than -2, you guys understand what that means. You also should be able to graph this representation. So if you were to sketch a graph, anytime you're graphing a number set, you always take your critical point. In here, the critical point is -2. And then you base your graph off of this. So if x is less than -2, which direction do we include the numbers? To the left or to the right? Less than is to the left. And so most of you are probably familiar with, you shade it in, and then you might put an open or closed circle here. In this case, -2 is not included, so you would put an open circle. And now, this can be confusing, and some of you maybe when you first started learning this probably cheated and put like 3/4 of the way filled circles so that you could argue, no, like that's open. No, that's a closed circle. Okay, so in order to avoid any of that confusion, there's a different set of symbols that are more commonly used than the open and closed circles. And the open circles are going to be rewritten as parentheses. This indicates exclusive. It's not included in the set. So in this case, instead of an open circle, we would replace it with a parentheses. A closed circle is going to be replaced with brackets. And this means inclusive, meaning that that set or that number with the bracket on it will be included in the solution set that's being indicated. Okay, so the x is less than -2 is really going to look like this for this year and probably beyond any of the classes that you'll take beyond this. Okay, we have the same kind of set. It's -2 is our critical point. We're opening to the left. We're excluding the 2, so we'll have a parentheses. And again, you can shade it or not shade it. The direction of the grouping symbol will indicate which direction your shading is contained in. Okay, so this is the graphical notation for x is less than -2. Okay, let's take a look at the following. Okay, let's say we have x where it's kind of sandwiched between two critical points. Okay, once again, you guys are probably familiar with being able to graph this. Label your two critical points, 0 and 10. Okay, the x solution set will be contained between these two. Okay, so you could shade it a little bit if you want, or you could just leave it. Because it's the grouping symbols that will show the interval set. Okay, so x is greater than 0. So is 0 going to be included in the set? No. So at 0 we'll have a parentheses, and the greater than 0 opens to the right. Okay, x is less than or equal to 10 though. So our other critical point at 10, is that going to have a bracket or parentheses? It's equal to, so it's going to have a bracket. And its x's are less than that, so less than is to the left. So that's going to open to the left. And so this represents the graphical notation for that interval. Okay, let's go back and talk here really quickly what the interval notation looks like, because the interval notation is the form that I will use the most often. Okay, interval notation basically takes your graphical form and writes it in a single line. Okay, so when you're setting up an interval notation, you always begin with your lowest limiting value. So in this graph, and often it's easiest to look at the graph, what's the lowest value, the furthest to the left? -infinity. So you do have to indicate that. -infinity is our lowest limit. Follow that by a comma. And then what's our upper limit? Negative 2 is our upper limit. So that's how we're always going to start interval notation. Lower limit, comma, upper limit. And then you need to decide what grouping symbols apply. So at this lower limit of negative infinity, can we ever actually reach that and include infinity? No, negative and positive infinity don't exist, so you can't actually include them. So anytime an infinity symbol exists on intervals, it'll always have a parentheses. Hey, what about negative 2? Bracket or parentheses? It's excluded, so parentheses. So this is the interval notation for x is less than negative 2. Now, in order to express this online, I'll use INF to represent the infinity symbol. So here's how you would actually enter this online if this was your answer. Negative INF, comma, negative 2, and the whole thing surrounded in parentheses. Okay, so what do you think the interval notation would be for this second set? Lower limit at 0, upper limit at 10. Will we have a parentheses or bracket at 0? Again, we're just taking right off of the graph. Parentheses or bracket at 10. Bracket. And so here is the interval notation for this second example. Okay, what if we took, let's take one final example here. If we took x is greater than or equal to negative 8, our graphic notation has negative 8. Is it going to open to the left or to the right? X is greater than means it opens to the right, and it's going to be a parentheses or bracket. Bracket. So this is all you need. As long as you put your bracket facing that direction, you're good. If you want to shade it in or darken it and draw the arrow, you can. Okay, and then the interval notation, our lower point is negative 8, upper point, infinity. The negative 8 has a bracket, it's included. Infinity can never be included, so it's a parentheses. And again, if you needed to see what this looks like, entered online. Bracket negative 8, comma, INF to represent infinity, parentheses would be your representation. Okay. All right, what I would like you guys to do is just take a moment to see if you can answer questions 2 and 3 on page 3 of the text regarding this terminology. Okay, anytime you have an infinity in your interval, these are called unbounded intervals. Meaning that one side of your solution set extends infinitely. There's no real number boundary on it. So this example down here is also an example of an unbounded interval. Anytime you have real numbers that are the limiting factors, the lower and the upper values, whether it's included or excluded, as long as you have real numbers on both sides of your x here or as your limiting factors, this would be referred to as a bounded interval.